When we're talking about arc length, we're talking about a piece of the circumference of a circle. So here it's labeled as A, that's the arc length. And that's what we're going to try to find in this question. The formula for arc length is A equals R theta. A equals R theta. Theta is the central angle measured in radians, and that's important. It has to be measured in radians. And R is the radius of the circle. The radius and arc length must have the same units. So it doesn't matter what the units are on those. If this is centimeters, then we're going to find, like the radius is centimeters, we'll find the arc length in centimeters. If the radians in meters, the arc length will be measured in meters. It doesn't matter what units you use for those, but it does matter that the central angle has to be measured in radians. So this one is 153 degrees is given as the central angle. We need to first change that to radians. So I'm going to go 153 degrees multiplied by pi over 180. That's going to be the angle measured in radians. So that's the theta. And then we also know that 5 centimeters is the R. So to find the arc length, it's equal to R, which is 5, multiplied by the angle, which is 153 degrees times pi over 180 degrees. I didn't actually switch it. I just put the conversion right in there. And then I'll figure out what that is, and that'll be our arc length. And I get 13.4 to the nearest hundredth, so 13.35 centimeters for the arc length. And that seems reasonable. If this is 5 centimeters, the radius, then we're saying that arc length is going to be about 3 times that, or a little less than 3 times that, so that looks like it worked out. This one asks you to find the angle and express your answer as a degree to the nearest hundredth. So we're going to start with the same formula, A equals R times theta, but in this case we know A is 6 and the radius is 3, which if we solve for theta, theta is equal to 2, and that means 2 radians. But it's asking us for the angle, and that does look like 2 radians. 3.14 radians would be like a half a circle, so 2 is about 2/3, or yeah, of the half. 2 radians. We want to change that to degrees because it asks for a degree to the nearest hundredth, so we'll multiply by 180 and divide by pi. Which is 114, did it say to the nearest hundredth? Yeah, 114.59 degrees. So it's a pretty straightforward formula to use as long as you remember that the angle has to be measured in radians. And then you can switch it. So if it gives it to you in degrees, switch it to radians. If it asks for it in degrees like this one did, then switch it after you find the angle. This one asks you to solve for R to the nearest hundredth. So again, A is equal to R times theta. Arc length here it says is 1.23 pi. And theta is pi over 2. It's already measured in radians, so I don't have to do anything with it. I just need to divide by pi over 2. and that comes out to 2.46 centimeters. That's all there is to it.